Hi, this is Mr. Schoonover and Ms. Christensen's States of Matter Interactive Activity Google Slides. This is the directions for how to do that and some examples. So first of all, let's go ahead and change your title of your slides to make sure that it has your name and it has some information so that when you go back to look at it, you can find it easily. So go up here and you can change it. I'm going to change it to Mrs. Christensen and States of Matter. Okay. Now let's go ahead and go to slide number 1. It says build your own solid, liquid, and gas. Drag and drop the blue pieces to create your own solid, liquid, and gas in the boxes to show particle behaviors for each. Describe the particle motion you are trying to represent in the gray box below your example. In order to move these blue circles, I'm going to click on the circle. Click on the circle, hold it down. Do not lift your fingers from the mouse or trackpad and drop it onto the white space under solid, liquid, or gas. Now, solids are very close together. The particles are super close. They are vibrating next to each other, and they have a definite shape and definite volume. So I'm going to try to get these as close as I can. So again, you click on them. You do not lift your fingers, and you drag it over to the box that you would like, and then you release the mouse. Okay, so I'm going to do that for a few rows because we want to show that it has a definite shape. And I'm trying to get them as close as I can. It doesn't have to be perfect. Okay. Yes, this is definitely not my best one that I have, but it is close enough, and it is, you can understand the idea of what was happening. Now, to answer the questions down below, how does this represent the particles in a solid? You click on the gray box, you highlight the text that's already there, and you delete it, and you can go ahead and start typing in your sentence. You can say, in this picture, the particles are, and then you can finish that sentence. Okay, and you're going to do the same thing for liquid and gas. Now let's go to slide 2. This is changes in state. So going from melting to freezing, or going from a solid to a liquid to a gas, or a gas to a liquid. All of those have certain vocabulary words that go with it, right? So if you go from a liquid to a solid, that is freezing. So you are going to describe what is happening, what states of matter are changing. So let's start with melting. I'm going to click on this gray box. I'm going to delete the text, highlight the text, and then delete it. And I'm going to say from solid to a liquid. Okay. If you want it in a good sentence, you can say changing from a solid to a liquid. It's not really a sentence, it's more still a phrase, but it still has more information. Now here you're going to click on it, and this one is asking, is thermal energy removed or added? Okay, our particles are going from a solid to a liquid, so you have to think about what is happening with the particles. So is that energy being removed or added? And then you're going to talk about in the last column, whoopsies, I moved it away. Okay. Describe the kinetic energy of particles after the change. What is happening when it is in that liquid state? What is happening to those particles? Those particles are sliding past each other, and they're not moving as fast as it would as when it was a solid. So that information is going in this box right here. If you happen to need more space, you can drag it down so that you can have multiple sentences. But what we want here is just some quick, brief information of what is happening. Okay, you're going to do it for the same for condensation, evaporation, melting, freezing, sublimation, and boiling. right, let's move on to slide 3. So slide 3, we have changes in state and motion of particles. So again, you're going to drag and drop the particles, this time they're green, to create a visual representation what each change in state looks like before and after the change. So we're thinking about the particles, what is happening to the particles. Are they getting closer together? Are they getting further apart? Are they vibrating? Are they sliding past each other? Or are they bouncing off the area? Describe the change you illustrated in the boxes below. So in freezing, we're going from a liquid, so from further apart. So I'm not going to put them as close together. I'm going to give them some space. Okay, again, you're dragging and dropping. All right, and then it's moving to a solid. So then they're going to be closer together. I'm going to put one more in here. Okay. Now, you have some questions down below to answer. Explain how the motion of particles changed. Oh my goodness. My mouse doesn't like me. Okay. Explain how the motion of particles changed. The motion changed from being slowly past each other to vibrating quickly next to each other. If the change was reversed, what type of change would recur? So we have if it was opposite, it would go from a solid to a liquid, and that would be melting. And lastly, is this thermal energy removed or added during the change? So you would either write removed or added in that box. You also have condensation and evaporation left to do. Now, research, real world examples. I can't help you out too much because you have to do the research, right? This is something that you would have to use Google for, and you can type in 3 different changes for melting, freezing, condensation, and sublimation. So you're going to briefly describe each example that you have. So when I think of melting, I think of an ice cream cone melting and getting your hand all sticky and yucky. But that's what I think of when I think of melting an ice cream cone. And then I also think of an ice cube melting. And there's some other examples that you can research and explain. So I accidentally moved that box. You can click on it again and move it back if you accidentally moved that. So in order to type, you're going to highlight the text and delete this, and you're going to give me an explanation. So in the ice cream cone example, the ice cream is a solid, and as heat is added to the ice cream, it turns into a liquid, a delicious liquid at that. Okay, you're going to do the same thing for freezing, condensation, and sublimation. This one is slide 5 is a vocabulary matching portion. So you are able to slide the Google Slides to the left. So notice how there is a bar down below, and you can scroll over so that you can see all the words and drag them over to the actual slide. So I have gases, temperature, kinetic energy, vaporization, condensation, thermal energy, liquids, and solids. So I'm going to start with definite shape and volume. Well, I know that is a solid, so I'm going to click on the solids rectangle, hold down my mouse, and drag it over to that first phrase. I'm going to try to get it as best as I can to the same phrase, but just try your best. You can move it up and down if you need to, or side to side, but it doesn't have to be perfect. Next one, a definite volume, but no definite shape. Well, I know a liquid has volume, but it takes the shape of whatever the container is. So I am going to drag liquids over here. And if it is helpful, if you can keep scrolling until you find it where it kind of looks like a T. You have two red lines intersecting that are perpendicular, and that will tell you that it's in the middle. So I can go ahead and drop that rectangle next to that phrase. So you have some more to do. You have 1, 2, 3, 4, 5, 6 more to do. Again, you're going to click on the name of the rectangle and drag it over to the phrase. All right, lastly, we have a Venn diagram where you are comparing similarities and differences. So solids versus liquids. We're going to enter information about the similarity and differences between solids and liquids into the Venn diagram. Include examples of solids and liquids. So on the outside part of the Venn diagram is going to be your differences. That's where you're going to put things that are not the same. When you type in the middle part where the circles are connecting or overlapping, that's where you're going to write things that are similar, that are the same. So, for example, solids and liquids, they both have, when they take the shape of something, they have definite volume. Okay, so definite, spell it correctly, definite volume. But because they have definite volume, the solids have a definite shape, where liquids do not have a definite shape. So I'm going to put definite shape. Right? The shape cannot be moved, but the liquids does not. It does not have a definite shape. And if you want to make your box bigger, you can go ahead and scroll that down so that it fits better. Okay. Another one, let's start with an example. Write an example. I'm going to write example of solids, but go ahead and you give me an example of a solid. Okay. And liquids here, go ahead and give me an example of a liquid. Now remember, you still have one more similarity to write in the middle, and then you have 2 more differences to also add to this Venn diagram. If you have any more questions, please reach out to Mr. Schoonover or Mrs. Christensen, and we will try our best to help you. Have a fantastic day, Lions, and this is due Tuesday, October 6th at 11:59. Please reach out if you need any help. Have a great day, Lions.